All right, guys. So today we're going to talk about rhombi and squares. And we need to remember these are still parallelograms, so there's lots of rules that we've already learned that apply here. A rhombus is a parallelogram with four congruent sides, and a lot of people see these as diamonds, okay? But all four sides are congruent, so it's sort of like a square in some ways. But remember, all the properties of the parallelogram a rhombus has, but it has two additional properties that are actually pretty useful to us. So let's look at this picture and mark it all. The things we already knew. Opposite sides are parallel. We've seen that before. It also says opposite sides are congruent. However, if I look at one of my new ones, I know that it also has four congruent sides, so those kind of go together, meaning all four sides are congruent. Opposite angles are congruent. So this angle is congruent to this angle, and these angles are also congruent. Okay? We know consecutive angles have a sum of 180 degrees, which means any two angles that are next to each other. So those two angles or those two angles or so on. Okay? It says the diagonals bisect each other. We've seen this one before. So that's congruent to that. That's congruent to that. Now, we get into some new things. The four congruent sides obviously was one of them, but the diagonals are perpendicular. That means when these diagonals intersect, they're all 90-degree angles, which is pretty awesome. And the diagonals bisect opposite angles as well. So that means these are bisecting, meaning these two individual angles right there are congruent, and they're also congruent to these angles that are opposite as well. Same thing on the other side. These two angles are congruent to these two angles. And that'll help us a lot when we're solving problems later. So I know that's a lot of stuff, and of course you can come and ask me questions in class, but let's use some of this and maybe it'll make it a little bit clearer. So I've got the measure of angle RST, which is from R to S to T. So this whole angle right here is 67 degrees. It wants me to find RSW, which is just this angle right here, okay? But I know that the diagonals bisect that angle, so those two angles are congruent. So what that means is the measure of angle RSW is equal to 1/2 of 67 degrees. So I can divide 67 by 2, and I get 33.5 degrees. So the diagonals bisect the angles and cut them in half. Example 2, it says find the measure of SVT. That's going to be this angle down here, okay? If the measure of STV, so this angle up here, the whole thing, is 135 degrees. Let me zoom in a little bit there. Now, this is going to take a few steps. It's not like those angles are necessarily related, but there are ways you could do it. I'm going to use triangles to do it. I know that this angle and this triangle over here, because it's broken into four triangles, is 90 degrees. I also know that this angle right here, I don't know why it keeps doing that, there we go, is congruent to that other little angle. So I can cut 135 in half, and it should give me the second angle in that triangle. I believe it's 67.5 degrees. So I'm going to write that in here, 67.5 degrees. And so is this one also, okay? But now I've got this triangle. I know a triangle has 180 degrees. I know one of the angles is 90. I know the other one's 67.5. So if I subtract those, it leaves me with the angle that we're looking for, which when you subtract those is 22.5 degrees. So the measure of angle SVT is equal to 22.5 degrees. Now, another way you could have done it, guys, is you should know, and I'm going to kind of erase a few things just so you can see it a little bit better. That didn't erase very well. That this angle and this angle add up to 180. So if you knew this was 135, 180 minus 135 would have given you 45 degrees for this, and then you could have divided it by 2 and got 22.5 as well. You use whatever makes you the most comfortable. Let's go to our picture over here, guys. Let me see if I can get to it. Notice that this angle right here is the same as this angle right here, and this one, and this one. So if you know one of them, page. Here's one of the easiest problems that we have is example 3. Says if the measure of angle SWT, which is right down here, is 2x plus 8, they want us to find x. Well, all you need to remember is that the diagonals are perpendicular to each other. So 2x plus 8 is equal to 90, which means 2x is equal to 82, which gives us our x value of 41. So that one's a pretty easy and quick one. Let's look at this next one. This is a pretty easy one too. It says find x if the measure of WRV is 5x plus 5. And again, knowing what angle they're talking about is important. You may not see what the answer would be. It also tells us WRS is 7x minus 19. Now I know from our rules that these two angles are congruent, which means the expressions are equal. So 7x minus 19 equals 5x plus 5. I'm going to subtract 5x from both sides and add 19 to both sides, and I get 2x equals 24, which makes my x value equal 12. Okay? Let's look at this last one. This is probably one of the more tricky ones. I mean, I have to kind of look at it really hard to get it sometimes, but filling it out is really going to be the important part. It says D to M. This whole diagonal from D to M is 24 units. It tells me that angle LDO, this angle up here in the top corner, is 43 degrees. And then it tells me that from D to L, this top one here is 13. And then it asks me a whole bunch of questions, so we're going to go through them kind of quick. OM, that's this piece right here. It wants to know that first. Well, I know the diagonals bisect each other, so these two are congruent. So that's going to be 1/2 of 24, which is equal to 12. So I know that's 12, and that's 12. So I now know OM. Then it asks me for DOL. This is probably the easiest one. That's 90 degrees because diagonals are perpendicular, so 90 degrees. Then it asks me for DLO, which is this angle right here. So again, we can use some of our triangle stuff to get this one. I know a triangle has 180 degrees, and I'm talking about this top triangle right here, okay? I know it has a 90-degree angle. I know it has a 43-degree angle, and if I subtract those, I get 47 degrees for this missing angle right here. So 47 degrees. And the rest is really just repeating itself. The next one asks for DML, which is this angle right here. Well, if I look back at my front page, it's actually fairly obvious. I know that this angle and this angle are congruent to each other, but they're also congruent to these angles, which makes that 43 degrees as well. So, and remember, know them all. And then it wants the length of DP. Well, that's really easy too because all sides are congruent. So if DL is 13, then DP is also 13. So there's a lot of stuff going on there, guys. Make sure if you're having any problems with this one in particular, make sure and ask me tomorrow because this really uses everything that we have. Now let's switch gears for just a second and talk about a square. I hope you all know what a square is. It's a parallelogram with 4 congruent sides and 4 right angles. So it's like a rhombus mixed with a rectangle, okay? All that stuff is true. So everything that we knew from all the shapes we've learned so far are present in our square. So things like opposite sides are parallel, and opposite sides and all sides are congruent. Opposite angles are congruent. I'm going to go ahead and kind of bring this into another one. All the angles are 90 degrees. So we know that, but we also know that each of these is 45 because the diagonals bisect the angles. I know that all the center angles are going to be perpendicular. And I know now, and this is what's great, is the diagonals bisect each other, but they're also, the diagonal lengths are equal, so all of the diagonals are the same. And then, of course, we have that the sums out here of consecutive angles is 180 degrees. So squares are by far the easiest shape because a lot of stuff is the same. It says math is a square, very important. It says from M to A, it's 8 units. Therefore, A to T, since they are congruent, would also be 8 units. It says find the measure of HST. So HST is this angle right here. Well, the diagonals are perpendicular, so it's 90 degrees. Then it says find MAT. But if you remember this one, it says you have 90-degree angles on each corner, so it's 90 degrees as well. Now here it kind of changes it up, and it's talking about the diagonals now. It says from H to S is 2. Therefore, from H to A must also be 2. And if those are both 2, so are these. And so from M to T would be 2 plus 2 would be 4. So a lot of the stuff's real consistent, especially with the angles. Just watch out when you do the diagonals and side links. Make sure you don't mess that up. The last problem. I know this one's been kind of long. We're going to use AB square ABCD and the given information to find all of the following. First, it says the measure of AED, this angle right here in the middle, is 5x plus 5. Well, I know, and it wants us to find x. I know that all those angles are 90 degrees, so 5x plus 5 equals 90, which means 5x equals 85, which means x equals 17. Now it wants us to, it says the measure of angle BAC, so this angle up here is 5x. And it wants us to find x. Well, if these are 90 degrees and the diagonal bisects it, then each one of those is 45 degrees. So 5x equals 45, which means x equals 9. Now, guys, I know not all this is super clear, but that's what tomorrow is for. So make sure you have all the notes down. Ask me questions tomorrow, and we can get it all cleared up. Good luck.